Okay, so today we're going to be rotating a vector, or vector 2, 1, 0, 180 degrees around the line R, 1, 1, 0. And we're going to use quaternions in order to do this rotation. Okay, the first thing that we're going to do is we're going to have to multiply Q times V, and then we're going to take that quaternion and we're going to multiply it by Q star. Okay, so the first thing we have to do is let's identify what we have. So this is our U, and this is our V, in terms of what we're rotating around. Okay, so U, U is equal to 1, 1, 1. U has to be a normalized vector. Okay, so what I'm going to do is I'm going to say 1, 1, and I'm going to divide that by its magnitude, which is going to make our U hat equal to 1 over radical 3, 1 over radical 3, 1 over radical 3. Don't worry about like rationalizing that radical here. We're just going to leave it in the denominator. This is equal to. Okay, let's remember our Q and our Q star. So our Q is equal to the cosine of theta divided by 2 plus U hat, that's this that we just calculated, times the sine of theta divided by 2. This right here, 180 degrees, is our theta. Okay, so if I plug this in, I'm going to go cosine of 180 degrees divided by 2 plus, I'm going to plug in for U hat, radical 3, radical 3, radical 3 times the sine of 180 degrees divided by 2. All right, so this is the cosine of 90 plus U hat times the sine of 90. The cosine of 90 is equal to 0 plus the sine of 90 is equal to 1. Okay, so this is our Q. This is our quaternion, that's our scalar portion, and this is our vector portion. While we're here, we'll also calculate Q star. So this is cosine of theta divided by 2 minus U hat sine of theta divided by 2. I'm going to plug everything in. So this is cosine 180 divided by 2 minus our U hat from before times the sine of 180 divided by 2. Don't forget the divided by 2. So this is cosine of 90 minus our U hat times the sine of 90. Cosine of 90 is 0 again. Radical 3, 1 over radical 3 times 1. I like to actually multiply this negative through on here, so my quaternion for my Q star is going to end up looking like 0, my scalar portion, plus minus 1 over radical 3, minus 1 over radical 3, minus 1 over radical 3. Okay, and then let's write out our Q here is going to be 0 plus 1 over radical 3, 1 over radical 3, 1 over radical 3. Okay, I multiply through by the negative because I'm going to need to use this this vector here in other types of multiplication and addition and stuff, and I want to remember that each piece is actually a negative piece. Okay, all right, so take a look at that. I'm going to have to erase it so that I have the whiteboard space. Okay, so our first bit of multiplication is going to be multiplying Q by V. This is going to be a quaternion multiplication. So the first thing I have to think about is turning V into a quaternion itself. So its first scalar portion is going to be 0 plus its vector portion. Okay, this is what I'm going to be multiplying by in terms of our Q, and in terms of our Q times V. Remember, quaternion multiplication is order specific, so this is Q times V. So I'm going to set this up, Q first, 0 plus 1 over radical 3, 1 over radical 3, 1 over radical 3, times 0 plus, now my V, 2, 1, 0. Okay, now remember with our quaternion multiplication, I have to multiply the scalar portions first, 0 times 0. I have to subtract out the dot product of these two vectors here. 1 over radical 3, dot product, 2, 1, 0. Okay, this is going to give me a scalar portion of my QV multiplication. Then I'm going to add in the vector portion, which is the vector portion of q cross product with the vector portion of v, plus the scalar portion of q times the vector portion of v, plus the scalar portion of v times the vector portion of q. It just happens in this case that our scalar portions of v and q are 0, so these things are going to be dropped out. Okay, let's take these piece by piece. So I'm going to do the dot product first. So 1 over radical 3 times 2 plus 1 over radical 3 times 1 plus 1 over radical 3 times 0. This is going to give me 2 over radical 3 plus 1 over radical 3 plus 0, which is 3 over radical 3. Okay, this is for my dot product. Now I'm subtracting 0 from this number. So my overall number is minus 3 over radical 3, because it's 0 minus 3 over radical 3. So that's our scalar portion, and now I need to do the cross product. I'm going to have to erase part of the board. Okay, so I'm going to erase my dot product part, and I'm going to do the cross product here. Okay, so let's talk about our cross product. So I'm going to say Q cross V. Okay, remember I set this up as I, J, and K. So my Q, my vector portion of Q is 1 over radical 3, 1 over radical 3, 1 over radical 3, and my vector portion of V is 2, 1, 0. Okay, and I'm going to erase this portion here so I have space to work. Okay, so let's go ahead and do it. So I have I times first row, first column, minus J, first row, second column, plus K, first row, third column, okay, now we're going to multiply things together. So this is going to look like I times, this is 0 minus 1 over radical 3, minus J times 0 minus 2 over radical 3, right, because I multiply these and I subtract them, plus K times, this is 1 over radical 3 minus 2 over radical 3. Okay, so then what I get is I times minus 1 over radical 3 minus J times minus 2 over radical 3 plus K times minus 1 over radical 3 to give me a vector minus 1 over radical 3. Oops. Minus times a minus makes it positive 2 over radical 3, negative 1 over radical 3. Okay, now that gives me the vector for the Q cross V. Now remember, I would say the scalar of Q times the vector of V, the scalar of V times the vector of Q. Now, each of these, okay, is equal to 0. Normally I would add out those results, but in this case they're equal to 0. So my resulting quaternion from this is equal to Q times V. Okay, I'm going to use this quaternion here when I go to multiply it by Q star. Okay, so remember this. I'm going to have to erase the board so that I can then do the next part. All right, so let's do QV, I'll put it in parentheses, times Q star, because we already did this. So let's write it out. So QV is minus 3 over radical 3 plus minus 1 over radical 3, positive 2 over radical 3, negative 1 over radical 3, times 0 plus minus 1 over radical 3, minus 1 over radical 3, minus 1 over radical 3. Remember, Q star we calculated before. Okay, so again, I'm going to multiply the scalar portions times 0, and I'm going to subtract out the dot product of these here. So this is going to be minus 1 over radical 3, 2 over radical 3, minus 1 over radical 3, dot. Okay, so let's do the dot product of this. Is going to be 0 minus, so let's do this. So this is going to look like minus 1 over radical 3 times 1 over radical 3, this one, then this one, plus 2 over radical 3 times minus 1 over radical 3 plus minus 1 over radical 3 times minus 1 over radical 3. Okay, so what I get here is positive 1 over 3. So this is radical 3 times radical 3 makes it 3. Okay, this is minus 2 all over 3 plus 1 all over 3. So 1/3 plus 1/3 is 2/3. Minus 2/3 is equal to 0. So we're looking at 0 minus 0. So my scalar portion of this multiplication here is simply 0. Okay, I'm going to erase that so I can do the next part. Okay, our next part is going to be the cross product of this vector and this vector here. So I'll call it QV cross Q star. So I have to set that up I, J, K. So I'm going to go like here, minus 1 over radical 3, 2 over radical 3, 1 over radical 3, minus 1 over radical 3, radical 3 minus 1 over radical 3. And then we'll take our dot product, cross product. So this is going to be I, first row, first column. Okay, and the next one. Minus J. Okay, first row, second column, I avoid those. And then plus K. First row, third column. Okay, let's multiply these out. So I'm going to get I times 2 over radical 3 times minus 1 over radical 3 minus a minus 1 over 3 minus J. Let's write this out. 1 over 3. I'm going to start multiplying things through. Times 1 over 3 plus K times 1 over 3 plus 2 over 3. Okay, so this is going to equal minus 2 over 3 plus 1/3. So then my total vector from here is going to look like minus 1, 0, positive 1. Okay, minus 2/3 plus 1/3. Okay. Oops, I'm sorry. This should be actually negative 1/3. So did I do this setup right? So here minus, oh, and then, sorry, this should be negative. So that would be negative, which would make this negative, negative, positive, but I'm subtracting, so I get a negative here. Minus 1/3. Okay, that's where I get this from. Okay, so that's our vector from the cross product. Okay, remember that? I'll write it down at the top. Now we're going to multiply the scalar portions through. Let's start building up our answer. So remember, our scalar portion was 0 plus, now my vector portion from here was minus 1, 0, 1, plus, now I have to do this scalar here, minus 3 over radical 3 times this vector here, minus 1 over radical 3. When I do this, I'm going to get, let's see, 3 over 3, right, comma, this is going to be 3 over 3, and this is going to be 3 over 3, which is equal to 1, 1, 1. Okay, when I do this scalar times this vector, it becomes a 0. So I'm only going to worry about adding these two together. So my end result is going to be 0 plus 0, 1, 2. Okay, so this is our final transformation. Remember, we took our original vector v, which was equal to 2, 1, 0, and we rotated it 180 degrees around the line 1, 1, 1 to get 0, 1, 2. I'm just going to come up with a really quick sketch in 3 dimensions so that you can see this is our x, this is our y, and this is our z. Okay, and it's going to look like I've got the vector 2, 1, 0. So here's my vector v. Okay, my vector u is 1, 1, 1. It comes up out of the board this way. I'm going to have to draw it like this. So bear with me here. Here's u. Okay, now my rotated vector is I go 0 in the x direction, 1 in the y, and 2 in the z. So here's my result. Right, so I've taken this vector and I've rotated it 180 degrees, and this is my result there. If you graph it out, it should look plausible, okay? Should be in the right ballpark.